Besides the Pythagorean theorem, right triangles have other relationships that are worth mentioning. There are two special right triangles that are used quite often. One is the 45-45 right triangle, and the other one is the 30-60 right triangle. In the 45-45 triangle, because two angles are equal, it is an isosceles triangle. Notice that an isosceles right triangle is actually half of a square. This is what makes the 45-45-90 triangle important. In the 45-45, the hypotenuse is whatever measure the legs are times the square root of 2. It is commonly called the 1-1 square root of 2 triangle because when we use the Pythagorean theorem to solve it, we square one leg 1, you get 1. And you square the other leg, you get 1. You add it up, it is 2. And the square root of the addition would be the square root of 2. Notice also that unlike the perfect right triangles we discussed before, this is not perfect because the square root of 2 is an irrational number. That means answer must always be rounded off according to the needs of the problem. In the 30-60 triangle, the relationship is 1 for the short leg, 2 for the hypotenuse, and whatever the short leg is times the square root of 3 for the longer leg. So if the short leg is 4, the hypotenuse is double 4 or 8, and the long leg is 4, the square root of 3. And if the hypotenuse is 14, the short leg is 7 or half, and the long leg is 7, the square root of 3. And if the long leg is 8, the short leg is 8 over the square root of 3. Remember, because we are going the other way, we divide instead of multiplying. Simplifying 8 over the square root of 3, we get 8 square root of 3 over 3. And the hypotenuse is 2 times 8 square root of 3 over 3. 2 times 8 is 16. So if the long leg is 8, the hypotenuse is 16 square root of 3 over 3. Let's do some examples to practice. Find the value of the sides that are missing. The sides that are missing in this 45-45-90 triangle is the hypotenuse and one leg. Because it is an isosceles right triangle, leg AB is equal to leg BC. So if BC is 11, then AB is also 11. And the hypotenuse is 11 times the square root of 2. Using 1.414 for the square root of 2, 11 times 1.414 is 15.6. The hypotenuse AC is 15.6. Another example. The diagonal of the square shown is 17. Find the length of one side of the square. Dividing the square in half, two 45-45-90 triangles are formed. Taking one of the triangles, we see that the hypotenuse is 17. To find the value of one of the legs, we divide the hypotenuse, 17, by the square root of 2. Using 1.414 for the square root of 2, 17 divided by 1.414 is 12.0. One side of the square is 12. Another example. Find the value of x and y. If the short leg of a 30-60-90 triangle is 18, then the hypotenuse x is double 18, or 36, and y is the value of the short leg 18 times the square root of 3. Using 1.732 for the square root of 3, 18 times 1.732 is 31.2. Y is 31.2 and x is 36. Another example. If the long leg of a 30-60-90 triangle is 13, find the length of the short leg and the hypotenuse. To find the long leg, we multiply the short leg by the square root of 3. But to find the short leg from the long leg, we must do the inverse and divide by the square root of 3. So using 1.732 for the square root of 3, we divide 13 by 1.732 and get 7.5. The short leg of the triangle is 7.5. If the short leg is 7.5, then the hypotenuse is double 7.5 or 15. One last example. Rectangle ABCD is made up of two triangles. Angle ACB is 30 degrees. Find the length of all four sides of the rectangle if the diagonal is 20. Because it is a rectangle, all four corner angles are 90 degrees. So if this angle is 30, this angle ACD is the complement, or 60 degrees. That means that what we have are two congruent 30, 60, 90 triangles. Taking one of the triangles, we realize that if the hypotenuse is 20, then the short leg of the triangle, or leg CD, is half of 20, or 10. And the long leg AD must then be 10 times the square root of 3. Using 1.732 for the square root of 3, 10 times 1.732 is 17.3. Because rectangles have opposite sides that are equal, then side AB is 10 and side BC is 17.3.